Hi guys, welcome to geometry class. Y'all want to tell everybody on the bus hello? All right. Homework tonight is on page 192, 2 through 33 even. It is on your syllabus. Today we're going to be talking about lines. So my first question is, where is this? In Rome, and what is it? The Spanish Steps. All right. All right. The reason I have a picture of this is because when we talk about slope, um, stairs, when contractors build stairs, they are concerned about the slope. The steeper the stairs, the larger the slope number. Oh. So the first thing I want to do is go over what slope is. Slope is the ratio of the change in the vertical distance, which is y sub 2 minus y sub 1 over the horizontal distance, which is x sub 2 minus x sub 1. The equation for slope is m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Remember, if you look at a graph, the y-axis is the vertical distance, and the x-axis is the horizontal distance. That's why the slope, or the equation for the slope, is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So over here we have some steps, and we see that they look like this. This distance from here to here is what we call the rise, and it is actually called a riser in construction. And the part you step on is the tread or the run. So my first example says to find the slope of a line that passes through the points 3, 4, and 6, 8. So we want to find the slope of this line. If on site homework, you would write down the equation every time you work the problem. You'll know the equation by the time the exercise is over. And I'm going to put m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. If you all would label your points, I think you're less likely to make careless mistakes. So I'm going to label this x sub 1, y sub 1, x sub 2, y sub 2. Now, you didn't have to start with 3, 4. You could have started with 6, 8, but you need to be consistent. So we take these numbers and we plug them in the formula. We get 8 minus 4 over 6 minus 3. We come up with a slope of 4/3. Next, we have some information on horizontal lines. Horizontal lines have zero slope. You might remember that because the word horizontal has a Z and an O in it. So hopefully you can remember that it has a zero slope. A horizontal line is always y is equal to some number. So maybe y is equal to 5 would be a horizontal line on 5. The problem up here says find the slope of a line and graph the line that passes through the points 2, 3, and negative 3 and 3. So once again, if you would label it x sub 1, y sub 1, x sub 2, y sub 2, and plug those into your equation, get m equal to 3 minus 3 over the slope of this line is 0, and we know that it is a horizontal line. So if you were going to graph these points, it would go over 2 and up 3. You would go over 3 and up to 2. So you have a horizontal line on y is equal to 3. This is a horizontal line on y is equal to 3. I'll remind you all that 0 divided by 4 is equal to 0, but 4 divided by 0 is undefined. So you can divide a number into 0, but you can't divide 0 into a number. Next, we have vertical lines. Vertical lines have undefined slopes or no slope. Once again, if you label your points, x sub 1, y sub 1, x sub 2, y sub 2, start it over again, get m is equal to 3 minus 1 over 3 minus 3. 3 minus 3, you get 0. Let's get m is equal to 2 divided by 0. This is undefined. Once again, if you were asked to graph this, you would plot 3 and 1, and you would plot 3 and 3. You get a horizontal line that looks like that. Everybody okay with that? The formula is m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So now we want to talk about positive slopes and negative slopes. If you have some graph paper, you might have to do it. When we talk about positive slopes, when you graph a line with a positive slope, the line rises to the right or points to quadrants 1 and 3. So when it has a positive slope, the line rises to the right and points to quadrants 1 and 3. So the first thing we'll do here is just find the slope of this line. Well, I'll tell you what, why don't we just go ahead and graph it. So we have a point at 1 and 2, and we have a point at 3 and 4. We have a line that looks like this. Once again, if you find the slope, I would label this x sub 1, y sub 1, x sub 2, y sub 2. So the slope is 4 minus 2 over 3 minus 1. So we get 2 over 2, or slope of 1. Like I said, it has a positive slope, so it rises to the right. The other thing to remember is as the slope, the number gets larger and larger, the line gets steeper and steeper. So if this slope were 7, then the line would be much steeper. If the slope were a number like 1/2 or 1/4, the line would be flatter. We talk about a negative slope. A line that has a negative slope points to quadrants 2 and 4, and it rises to the left, or we could say it falls to the right. So here we have 0 and 2. And we have 2 and 0. and it has a negative slope. Once again, we need to find the slope. So we'll say x sub 1, y sub 1, x sub 2, y sub 2. So the slope of this line is 0 minus 2 over 2 minus 0. We have negative 2 over 2, or a slope of negative 1. Next, I'd like to talk about parallel lines. You know that the two lines are parallel if they do not intersect and are in the same plane. So parallel lines do not intersect and they are in the same plane. The fact they are in the same plane and do not intersect, those are important parts of the definition. Parallel lines have the same slope or equal slopes. Parallel lines have the same or equal slopes. So I'm going to ask, what are skew lines? Anybody remember? What are skew lines, Davis? They're not in the same plane and they do not intersect. So skew lines do not intersect and are not in the same plane. Remember, I said an example might be the railroad tracks with the telephone pole next to them. And so skew lines do not intersect and they are not in the same plane. Parallel lines are in the same plane and they do not intersect. So the example that I have up here says, given the lines that pass through the point 2, 2, and 4, 0, and pass through the points negative 1 and 1 and 2 and negative 2, determine if they are parallel. So determine if they're parallel, what we want to do is compare the slopes. So we want to compare the slopes, so compare slopes. So that means we have to find each one of these slopes. So we'll start with what I'll call the red line. So the red line, we have x sub 1, y sub 1, x sub 2, y sub 2. So we have 0 minus 2 over 4 minus 2. We get negative 2 over 2, our slope is negative 1. So this line, which is 2, 2, and 4 and 0, which we call in our red line, has a slope of 1, negative 1. Slope of negative 1. We want to find our slope of what we'll call our blue line, and that's going to be x sub 1, y sub 1, x sub 2, y sub 2. So we're going to say negative 2 minus 1 over 2 minus a minus 1. So we get negative 3 over 3, or negative 1. Because these lines have the same slope, they are parallel. So we have negative 1 and 1, and we have negative. So because the slopes are equal, the lines are parallel. That is the only way to tell if they are parallel. The graph may not be accurate, so you need to compare the slopes. Probably did a lot of this in Algebra 1, so hopefully we can go back. Perpendicular lines. What do you know about perpendicular lines? They intersect to form right angles. Right. Perpendicular lines intersect to perpendicular lines have negative reciprocal slopes, or we could say the product of their slopes is negative 1. So once again, you're asked to determine if the lines are perpendicular, and you're asked to graph the lines. So the first thing we want to do is compare the slopes. So we'll start with the blue line. And we'll say x sub 1 to y sub 1, x sub 2 y sub 2. So the slope is equal to 5 minus 3, and 6 minus 3, so we get 2/3. So the slope of the blue line is 2/3. So we'll go ahead and graph the blue line. We have 3. And we have 6. We have our blue line here. In order for the red line to be perpendicular to the blue line, it has to have a negative reciprocal slope. So let's see. What is the reciprocal of 2/3? What's the reciprocal of that number? The reciprocal is 3/2. And what would the opposite sign of that be? Negative 3/2. So our slope for our red line would have to be negative 3/2. So we need to find out if it's that is. So we have x sub 1, y sub 1, x sub 2, y sub 2. So we have m is equal to negative 6 minus a minus 3 over 4 minus 2. We get the slope of this line as negative 3/2, which is in fact the negative reciprocal. So because these are negative reciprocals, we know that these lines are perpendicular. So we have 2 and negative 3, and we have 4 and negative 6. So because they are negative reciprocal slopes, we know that these two lines are perpendicular. I have two postulates which are on your green sheet. The first one says two non-vertical lines have the same slope, if and only if they are parallel. And two non-vertical lines are perpendicular if and only if the product of their slopes is negative 1. The two examples that I have up here are similar to some of the homework exercises. The first example says determine the slope of the line. So all you're going to do is plug the information into your formula. So we have 3 minus 2 over 7 minus 0, and we have 1/7. And the slope of this line is 1/7. If we graph this line, you'll see that it's fairly flat. So we have 0 and 2. Long. That's 0 and 2. And we have 7 and 3. So you see where this line is fairly flat? Everybody see that? Alright. The next problem asks you to determine if the lines are parallel. The next problem asks you to determine if the lines are parallel, so you want to find the slope of each line and then compare the slopes. So we'll start with the red, x sub 1, y sub 1, x sub 2, y sub 2. We have the slope is 5 minus 4 over 4 minus 2. We have this slope is 1/8. are these lines parallel, perpendicular, or neither? Parallel lines have the same slope. Do these lines have the same slope? No. Perpendicular lines have negative reciprocal slopes, or the product of the slopes is -1. So what's the reciprocal of 1/2? The reciprocal of 1/2 is 2, but the negative of that, or opposite sign, would be -2. But these are negative reciprocal slopes, so you can multiply them together, and if you get -1, they are perpendicular. And we can say that these lines are perpendicular because they have negative reciprocal slopes. Okay. All right, some of the homework exercises tonight give you a graph and ask you to find the slope. So basically, you have to find the points on the graph, and then plug it into the formula. So here we have x sub 1, y sub 1, x sub 2, y sub 2. Once again, it doesn't matter which one you start with, as long as you're consistent. So we have -1 minus 2 over 0 minus a minus 1. So I have -3 over 1, so it has a slope of -3. Go back and look. Is it going in the right direction to have a negative slope? Right. So the slope of this line is -3. Like I said, they're just giving you a graph, and you have to pick the points off, plug them in the formula, and come up with the slope. Okay? All right, so let's go back. The homework exercises are on page 192, numbers 2 through 33 even. All right, so the first thing I would like to do is look at this particular problem, number 9, on last night's homework. On number 9, you got something that looks like this. This is not the greatest picture, but it'll do, right? You've got angle 1 here, you have 60 degrees here, you have 100 degrees here. Like I said, these problems do show up on the ACT, and so I think it is helpful to learn how to solve them. I would probably go through and write all the information I know down. I know that that's 50, this is 50, this is 130, that's 130. That's 100, this is 100. And that makes 680, and this is 680. And you're not going to use all this information, but I would write it down. The next thing you need to do is draw yourself a line. So let's look at some lines. We'll draw this line right here, from here to here. Okay. I made it perpendicular, so I know that this angle is 90 degrees. I know that that angle is 90 degrees. So I'm going to put 90 degrees here, 90 degrees there. Now there's a little formula that we haven't talked about yet. Kind of drives me crazy that they introduced this without talking about it. But, and the formula says n minus 2 times 180 is equal to the degree of the angles in a polygon. So how many sides does this polygon have? 5. So we would say 5 minus 2 times 180 would give you the total degree of the sum of all the angles. So we have 3 times 180. So we get that this pentagon has 540 degrees. So we want to take all the angles that we have. So we'll start with this one. That's 130. Then we got 90. Then we got 90 more. Then we have 100. And then we have angle 1. We don't know angle 1. That's what we're looking for. So I add angle 1. And then we know all of those add up to 540. So here we have 130 plus 180 plus 100 plus angle 1 is equal to 540. So here I get 310 plus 100. Somebody check my number. Is that right? So I have 410 plus angle 1 is equal to 540. So angle 1 is equal to 130 degrees. All right, hold on. Good question. Let's look at the picture. We have this piece, that piece, this piece, that piece, that piece. How many sides are there? 5. Okay. So it has 5 sides. That's why we know it's a trigon. So that's got n is equal to 5. And the formula, like I said, is n minus 2 times 180. All right. So do we have time to work problem number 10? Number 8. Got something that looks like this. We told you that this is parallel to this, parallel to this. All right. So if you have to move these around, I would. I don't know if I can alter the whole thing, but turn it sideways if you have to. Okay. Turn it back. All right. So what do you know about this angle and this angle? They're vertical. So I know that this angle is 3y. What do I know about these two angles? This angle and this angle. They're same-sided interior, so they add up to how much? So I could say 5y minus 4 plus 3y has got it to 180. So I have 8y is equal to 184. So y is equal to what? 23. How many what? Sides to what? All right, so I have that y is equal to 23 degrees. So if y is equal to 23 degrees, how much is this angle in here? 69. Because 3 times 23 is 69. What kind of angles are these angles? Corresponding. So corresponding angles are equal, so I know that 2x plus 13 is equal to 69. So 2x is equal to 56, is that right? So x is equal to 28. So for your answer, you should have gotten x is equal to 28 and y is equal to 23. Who's got the next question? On problem number 21, I gave you this was 60 degrees. I gave you angle 1. I gave you this was 20 degrees. So if this is 20 degrees, how much is this angle, y'all? 160. If this is 60 degrees, how much is this angle? 120. All right, so back to draw on a straight line over here. So Abby, what would this angle be? About a 90. How many sides are there? There's 1, 2, 3, 4, 5. It has 5 sides, so you could say 5 minus 2 times 180, and you're back to 540. So we have 120 plus 90 plus 90 plus 160 plus angle 1 has got it equal 540. So I have 120 plus 180 plus 160. Yes, Abby? You add up all the ones on the inside of the pentagon. Only the ones on the inside of the pentagon. So here I have 460 plus angle 1 is equal to 540. So I get angle 1 is equal to 120. That's not right. It's equal to 8. 460 from 540 is 8. So angle 1 is equal to 80 degrees.